Hi friends, this is the part 2 concept video of limit, continuity and differentiability concepts. I already explained some definitions and concepts about limit in part 1 video. In this video, let us discuss the remaining definitions and concepts. Now let's move the concepts. First, limits at infinity. Let f be a function defined on some interval a comma infinity, then limit extends to infinity f of x equal to L. This means that the value of f of x, the values of f of x can be made arbitrarily close to L by taking x sufficiently large. Limit at extends to infinity f of x equal to L. Next, let f be a function defined on some interval minus infinity comma a, then limit extends to minus infinity f of x equal to L. This is also the values of f of x can be made arbitrarily close to L by taking x sufficiently large negative. That means extends to minus infinity. This is the definition of limits at infinity. Next, one result, if r greater than 0 is a rational number, then limit extends to infinity 1 by x power r equal to 0. This is one result. Limit extends to infinity 1 by x power r equal to 0. Next, I am going to explain one example of how to evaluate limit at infinity. Limit at extends to infinity. This is the problem. Limit extends to infinity. One function 3x square minus x by 2 etc. The limit at infinity of any rational function, we first divide both numerator and denominator by the highest power of x that occurs in the denominator. This is the procedure. So limit extends to infinity 3x square minus x square, it will becomes limit extends to infinity. Here x square is highest power, so I take outside x square 3 plus minus 1 by x minus 2 by x square divided by, here also the highest power is x square, so 5 plus 4 by x plus 1 by x square. Here x square cancel, and by using that result limit extends to infinity at 1 by x power r equal to 0. So this value, this value, this value, this value is 0. Finally I got 3 by 5. So the final answer is 3 by 5. The next definition, horizontal asymptote. The line y equal to L is called a horizontal asymptote of the curve y equal to f of x if either limit extends to infinity f of x equal to L or limit extends to minus infinity f of x equal to L. This is the horizontal asymptote. Then y equal to L is called the horizontal asymptote of the curve. Next, indeterminate form and L'Hospital rule. Okay. What is indeterminate form? While computing the limits of certain function f of x, we may come across the following situation, that is 0 by 0, like z infinity by infinity, 0 into infinity, etc. These are called the indeterminate form. These forms are called the indeterminate form. Suppose you get indeterminate form when you are computing the limits of a certain function f of x, then you can use or apply L'Hospital rule. Okay. So what is L'Hospital rule? The L'Hospital rule says that the limit of quotient of functions is equal to the limit of quotient of their derivatives. Limit of quotient of function is equal to the limit of quotient of their derivatives. Now I explain one problem how to find the limit by using L'Hospital rule. For the first problem, limit extends to 1. Apply x equal to 1, we can get limit extends to 1. 1 square minus 3, 1 minus 3 plus 2, 3 minus 3, 0 by 0 form. This is the indeterminate form. So you can apply L'Hospital rule. What is L'Hospital rule says? Limit of quotient of function is equal to the limit of quotient of their derivatives. So by using L'Hospital rule, limit extends to 1, the derivative of numerator is 2x minus 3 divided by the derivative of denominator is 2x by 4. I can write by using L'Hospital rule. Now I substitute the limit, we can get 2 minus 3 minus 1, 2 minus 4 minus 2. So finally I got 1 by 2. 1 by 2 is the answer. This is the one example. This is the example of the indeterminate form 0 power 0, 1 power infinity and infinity power 0. Suppose you got the indeterminate form, these three forms, then you have to use this method. So first I substitute the limit value 1 plus sine 0 is 0, cot 0 is infinity. I got 1 power infinity. So I took the limit function as y. 1 plus sine 4x whole power cot x. The next step is I take log on both sides. Log y equal to log of 1 plus sine 4x whole power cot x. By using logarithmic rule, cot x log of 1 plus sine 4x. Next, I took limit extends to 0, log y equal to limit extends to 0. I can write cot x is 1 by tan x. So, in denominator I can write tan x log of 1 plus sine 4x. Now I substitute the limit value sine 0 0, log 1 is 0 and tan 0 is 0. Finally I got 0 by 0 form. So here I use L'Hospital rule, that is the denominator derivation is 1 by 1 plus sine 4x. Log x is derivative of log s is 1 by x. So and 1 plus sine 4x differentiation is 4 cos 4x by tan x differentiation is 6 square x. Now I substitute the limit. I got 1 by 1 sine 0 0 cos 0 1. So finally I got 4 and 6 0 is 1. So 4. Limit extends to y log y equal to 4. So limit extends to 0 log y, not log y, y. The given function is y. Y equal to, here I take logarithmic function. So here I take exponential function. These two functions are reverse. So reciprocal function. So I take the exponential function. I got the answer. So the final answer is e power 4. These two are the example of how to find the limit by using L'Hospital rule. Continuity. A function f is continuous at a number a if limit extends to a f of x equal to f of a. If f of limit extends to a f of x equal to f of a means limit exists. F is continuous at a, f of a is defined, that is a is in the domain of f and limit extends to a f of x exists and that limit also equal to f of a. Suppose f is not continuous, then it is called discontinuous. But geometrically, you can think of a function that is continuous at every number in an interval as a function whose graph has no break in it. The graph can be drawn without removing your pen from the paper. This is the meaning of continuity. Next, I will give one example. F of x equal to 1 by x square if x not equal to 0, 1 if x equal to 0. Here, f of 0 equal to 1, but limit extends to 0, f of x equal to limit extends to 0, 1 by x square. This is infinity. That means limit does not exist. Infinity means limit does not exist. So here limit extends to 0, f of x not equal to f of 0. In this case, f is not continuous. Not continuous means discontinuous. F is discontinuous. Next, I will give another one example. Here the function I discussed the function f of x equal to greatest integer x, greatest integer function. This is the graph of greatest integer function. The greatest integer function f is defined by the largest integer. The greatest integer function x is defined by the largest integer that is less than or equal to x. For example, the greatest integer value of 4 is 4. But the greatest integer value of 4.8 also 4. This is the definition of greatest integer function. So I draw this one. 0 to 1, the greatest integer function value is 0. And in the value of x, 1 to 2, the greatest integer function value is 1 only. So I draw the graph is 1. 2 to 3, the value is 2. Minus 1 to 1, 0, the value is minus 1. This is the diagram of greatest integer function. By using that diagram, the greatest integer function x equal to 3 for what values? 3 less than or equal to x less than 4. So limit extends to 3 plus from the right, okay, from the right 3 to 4. So from the right, the greatest integer value of x equal to 3. But the greatest integer function of x equal to 2 when for 2 less than or equal to x less than 3. So limit x tends to 3 minus. Minus means from the left value greatest integer function equal to 2. Generally we can write, here I write 3 only. Generally we can write limit n tends to x tends to n plus greatest integer x equal to n, but limit x tends to n minus greatest integer x equal to n minus 1. This is not equal to f of n. And here right hand limit is f of n. Right hand limit is f of n, but left hand limit is not equal to f of n. So in this case, greatest integer function x is discontinuous. Discontinuous. This is the another one example. Next, a function is continuous from the right at a number a, then limit extends to a plus f of x equal to f of a. Similarly, is continuous from the left at a, then limit extends to a minus f of x equal to f of a. Next one is a function is continuous on an interval if it is continuous at every number in the interval. Next, some results in continuous function. If f and g are continuous at a and c is a constant, then the following functions are also continuous: f plus g, f minus g, cf, fg, product, sum, subtraction, constant multiplication, and product and division are also continuous. Next, any polynomial is continuous everywhere, that is continuous on. Okay, any rational function is continuous wherever it is defined. Okay, next. The following types of functions are continuous at every number in their domains, that is polynomial, rational function, root function, trigonometric function, inverse trigonometric function, exponential function, and logarithmic functions. Next one is if g is continuous at a and f is continuous at g of a, then the composite function f composite g is continuous at a. Once again I explain, g is continuous at a and f is continuous at g of a. Then the composite function also continuous function at a. Next, I am going to explain what is derivative. The derivative of a function f at a number a denoted by f dash of a is f dash of a equal to limit h tends to 0 f of a plus h minus f of a h divided by h if this limit exceeds. F dash of a limit exceeds. That means if we write x equal to a plus h, then we have h equal to x minus a and h approaches 0 if and only if x approaches a. Therefore, the equivalent way of stating the definition of the derivative is f dash of a equal to limit x tends to a f of x minus f of a divided by x minus a. These two statements are equal. These are the definition of derivative. Next, I am going to explain how to find one derivative value of the function. Derivative of the function of f of x equal to x square minus 8x plus 9 at the number a. By the definition, f dash of a equal to limit h tends to 0. This is h. h tends to 0 f of a plus h minus f of a divided by h. So, limit h tends to 0 f of a plus h is a plus h whole square plus minus 8 into a plus h plus 9 and minus of f of a. What is the value of f of a? A square minus 8a plus 9 divided by h. Here h tends to 0. So finally I got limit h tends to 0, 2a plus h minus 8. So h tends to 0. The simplification, finally I got 2a plus h minus 8. Here limit h tends to 0. So the final value is 2a minus 8. So the derivative of the function f of x at the number a equal to 2a minus 8. The final result is any differentiable function must be continuous at every point in its domain. So any differential function must be continuous. The converse does not hold. A continuous function need not be differentiable, may be differentiable and may not be differentiable. This is the last result. These are the important definitions and results in limit continuity differentiability concept. In the forthcoming videos, let me solve previous year CATE questions related to this concept. If you have any doubt in this topic, then you can ask in the comment section. Let me try to clarify your doubts. Thank you. See you in the next video. If you like this video, please like, share and subscribe my channel to encourage me. Thank you.